All right, so welcome to this revision session. We are going to be looking at the mid-semester examination paper. Okay, so this paper has three sections. There's section A, B, and C. Okay, we are going to do and solve questions from all the sections. Okay, so we start from section A, which has multiple choice questions. But of course, since it's math, you also have to solve. Okay, you also have to solve and justify the option that you're going to pick as your answer. Okay, so we start from section A, question 1.1. So this is the question here. So here they're saying a nurse is monitoring blood sugar levels in millimoles per liter for two patients over a period of time. She observes that the glucose levels for patient A, patient 1, I mean, are defined for the interval 4.3 to 9.7, where the 4.3 is included, the 4.7 is not. And then for patient 2, the interval is 5.1 to 10.2, with both ends not included. Which of the following defines the intersection of these two blood sugar intervals? Okay, so the first one is 4.3 all the way to 9.7. Okay, and then the other one is 5.1 all the way to 10.2. So the easiest we can find this intersection is by using the number line. So the lowest number that I can see here is 4.3, and then comes 5.1, 9.7, and then 10.2 somewhere. So let's plot this on this number line. Okay, so for this one, this 4.3 is included because I have a square bracket there, and then I'm going all the way, okay, to 9.7, which is not included. For this one, the 5.1 is not included, even the 10.2 is not included. So the intersection is between here. Okay, where I'm shading there. So the intersection is just from 5.1 all the way to 9.7. But then we have to decide what kind of brackets do we put at the end. Okay, so when you look at this guy, it has an open circle there on 5.1. So I put a curved bracket. Even this one on the 9.5, I can see an open circle. So I just put a curved bracket. Okay, so now I go on the options and search if I have such an option. So as I go there, I'm going to pick option D as my best answer. Okay, so if you have any questions, just feel free to unmute yourself and then you can ask. Okay, otherwise I'll go to question 2. Question 2, they're saying a physician, okay, orders 2.85 grams of an injectable drug solution for a patient. However, only a vial of the solution with a dose strength 55 milligrams, okay, per 2 milliliters is available at the hospital pharmacy. What volume of the on-hand solution should be administered to this patient? Okay, so here we have this mass and want to find a suitable volume for it. So we've been told the dose strength that is there is that for every 55 milligrams, okay, you will need 2 milliliters. Okay, so here the first thing is to change, okay, this mass in grams to milligrams. Okay, so how do I change those? I have to multiply by 1,000. So I'll say 2.85 multiplied by 1,000. Okay, it will give me 2,850 milligrams. So what volume will this need? So I put X. And then I just cross multiply. So I'll do 55X is equals to 2,850 multiplied by 2. I divide both sides by 55. So X will just be equals to what? Okay, so 2,850 multiplied by 2 divided by 55. What do I get? Okay, so divided by 55, I get 103.63 63663. So they continue to repeat. So if I round this off to one decimal place, I'll just get 103.6. So that will be my answer there. So I go on my options. I'm going to select B as my final answer. Okay, so any questions you're free to ask. Otherwise, I'll move to the next question. Okay, so question 1.3, they're saying an IV bag contains 1,200 milliliters of maltodextrin in saline solution with a drop factor of 12 drops per milliliter, and has been set to run for 5.4 hours. Find the rate flow of this solution in drops per minute. Okay, so the rate flow is found by, okay, the number of drops, meaning total drops, okay, divided by the total time. Okay, so here, how are we going to find the total drops? Okay, we're going to multiply the drop factor multiplied by the volume that is available. So the drop factor there is 7 drops, okay, per milliliter. And then the volume is just 1,200 milliliters. So you see here that even the units for the volume are going to cancel. So I have 7 drops multiplied by 1,200. So 7 multiplied by 1,200, it gives me the total drops to be 8,400 drops. Okay, so that's what I'll put on top. And then I have to find the total time in minutes. So this one here has been given in hours, 5.4 hours. So what do we do to convert that time to minutes? We're going to multiply this 5.4 multiplied by the 60, because we know that in 1 hour, we have 60 minutes. Okay, so 5.4 multiplied by 60, this gives me 324 minutes. So now I'm going to divide these two. So I have 8,400 drops. Okay. I can even put the units divided by 324 minutes. So when I divide this, what do I get? So I have 8,400 divided by 324. So I get 25.925929. So I can round this off to the nearest whole number. I get 26, and this will be drops per minute. So you go on your answers, you check where you have the 26 drops per minute. We see that it's going to be on option, now what I'm doing. It's going to be on option D there. Okay, so option D, that will be the answer there, 26 drops per minute, according to our calculation. So if you have any questions, please feel free to ask. Okay, so I'll move to question 1.4. So question 1.4, they're saying an IV bag contained 650 milliliters, okay, of a solution, and its infusion into a patient's bloodstream was started at 9 hours, okay, and it ran up to 15:32 p.m. with the rate flow, okay, so rate flow of 5 drops per minute. Okay, so now they're saying at 15:32 p.m., the IV bag contained 130 milliliters of this solution. So now notice this. At the beginning, we're at 650. At the end, we have 130. So this means there's an amount of volume that has been infused into the patient's bloodstream. So volume infused is going to be equals to the volume at the start minus the volume at the end. Okay, so that is 650 minus 130. So that gives me 520, okay, milliliters. So this is the volume that has been infused, okay? And then what time has elapsed? So let me find the time that has elapsed, okay? So the total time is from 9 hours to 15:32. So if I subtract those two, what am I going to get? Okay, so 15:32 subtracted by 9 hours, I'm going to get 6:32 minutes. Okay, so this is the time that has passed. So that time, because this drop factor is in minutes, I have to express this whole time in minutes. So the 32 is already in minutes. I just have to convert the 6 hours to minutes. So 6 multiplied by 60 is going to give me 360 minutes. So the 360 minutes plus the 32 minutes, okay, it's going to give me 392 minutes. So meaning this is the total time that it took. Okay, that's the total time that it took. So now, to find, what are we finding here? We're finding the drop factor. Okay, so to find the drop factor, okay, we need total drops. Okay, we need the number of total drops and then divided by the volume infused. So the number of total drops here are just going to be the flow rate, which is 5 drops, okay, per minute, multiplied by, okay, multiplied by the total time. Because if there are 5 drops per minute, what about in 392 minutes? So I'm going to multiply by 392 minutes. And then I divide by the total volume there, the volume infused, I mean, so 520 milliliters. So we see here that some units are going to cancel, the minutes and the minutes will cancel, so I only remain drops on top. So I have 5 multiplied by 392 drops. Okay, so that gives me 190. 19 skis, I mean, and then divided by 520. So this is in minutes, this is in drops. I mean, this is in milliliters, not minutes. Okay, sorry for that. So this is milliliters like this. This is drops. And then this is also milliliters. Okay, so let's divide those two numbers. So my calculator says 3.76923. Okay, so this will be drops per milliliter. So now I'm going to round it off to the nearest whole number. So it's going to give me 4. Okay, so you just come here and pick 4 as your best what? Answer. So you pick C as the best answer there. So any questions there? Okay, so if there are no questions, let's move on to question 5. Question 5 is very simple. They're saying a 53-year-old man, okay, with sepsis is administered a single 1,200 milligrams IV dose of meropenem, okay? After distribution, the plasma concentration is measured as 20 milligrams per liter. What is the volume of distribution of meropenem in this patient? So volume of distribution indicated by VD is equals to the dose over the plasma concentration. Okay, so the dose is this guy. And then the plasma concentration is 20 milligrams per liter. Okay, so if we divide this, or I should write it in this form so that we see how the units are canceling, divided by 20, 20 milligrams per liter. Okay, so this is the same as 200 milligrams multiplied by the liter goes up, and then the 20 milligrams comes down. So it means I'm just dividing this number by 20. Okay, so if I do that, what am I getting? So 1200 divided by 20, I'm getting 60. So these units and these units cancel. So this is 60 liters like this. Okay, so you come here and pick option A as the volume of distribution. Okay, so very simple questions, right? So let's look at question 6. Question 6, again, it has been repeated, this one. I've seen it in the quizzes. I've seen it in the tutorial sheets. I've seen it in the test. And it was also in the exam. So expect such a question in your final exam. Okay. So here they're saying a doctor is studying the spread of a virus in a population and models the number of infections over time using this quadratic equation here. Okay, so where IT represents the number of infections at time t in days, and then what is the maximum number of infections and on which day does it occur? So here we're just finding the turning point of this quadratic function. Okay, so the variable that we are using here is t. So I'm going to say the t coordinate of the turning point is minus b over 2a. So now remember the general form of a quadratic equation. Okay, plus c. So the coefficient of t squared is my a, the coefficient of t is my b. So this will be equals to, okay? The coefficient of b, the coefficient of t, I mean, is 12. So that will be minus 12 divided by 2 multiplied by a, which is the coefficient of t squared. So that is minus 1. So there I'll just have minus 12 divided by minus 2, which will be 6. Okay, so this maximum will occur on day 6, but what will be the maximum? Okay, so the maximum will be I of 6. So this will be minus 6 squared plus 12, 6 minus 20. So just punch this now into the calculator. So you say minus 6 squared plus 12 multiplied by 6 minus 20. So that gives me 16. Okay, so the maximum number of infections will be 16 and it will occur on day 6. So we come here and choose option B. Okay, so any questions there, guys? Okay, so if there are no questions, let's move on to the other part. This is question 7. Yes, question 1-7. So here they're saying solve the following equation. So this we have 2 log 2x is equals to log 2, 6, 4. Okay, so here by the properties of logs, we can say we can raise this 2 to be the power on the x. So it will be log base 2x squared is equals to log base 2, 64. So when you reach here, there's a number of ways, different ways, okay, in which we can find the value of x. But the easiest here is just to notice that I have a log 2 here, and then I have a log 2, and then I have a number here, and then I have a number, and then here I have a equal sign. So it means here, whatever is here, okay, should be equals to that, because these two are equal. Okay, so as long as the base is the same there. So if the base is same, then what is there should be equal. So it means here x squared should be equals to 64. So take the square root here, because the square root there, x will just be equals to the square root of 64, which will just be 8. So the answer there, we're going to pick A, which has 8 there. Okay, next question is question 8. Here they're saying what? Solve the equation. So they have 25 to the power x plus 1 is equals to 125 to the power 2x minus 1. So here the secret is to express this 25 and this 125, okay, as a 5 raised to power something. So we know that 25 is the same as 5 to the power 2, and then 125 is the same as 5 to the power 3. So I'm going to replace those two numbers. So it will be 5 to the power 2, and then I have x plus 1 is equals to, here it will be 5 to the power 3, and then I have 2x minus 1. Okay, so I can multiply or expand the power, okay, or distribute this power to this. So it will be 5 to the power 2x plus 2 is equals to 5 to the power 3 multiplied by 2x, that will be a 6x, then minus 3. So now we see that the bases are the same, so it means the powers should also be the same. So you cancel out the powers, you're going to remain 2x plus 2 is equals to 6x minus 3. Okay, so what are we going to get? So like terms together, what can we make here? Okay, if we do like terms together. Okay, like terms together, what do we get? Can I see an answer here? I can't seem to find an answer, but let's finish it. So okay, I can see it now. So this 2 goes to the other side, this one comes to the other side. So it will be 2, this one, and then the minus 3 comes there, it will be plus 3 is equals to 6x, because the 2x goes to the other one, so it will be minus 2x. So I have 5 is equals to 4x. Then I divide by 4, divided by 4. It means my x will just be equals to 5 over 4. So do we have a 5 over 4 somewhere? Okay, yes, I can see it. The 5 over 4 is there. So we're going to choose the option B as our best answer there. Okay, so let's move to question 9. Unless you guys have questions anyway. So question 1.9, they're saying if we have y is equals to 49 over 16 and then x to the power 4. Okay, and we express 16y to the power half in the form k x to the power n, where k and n are integer constants to be found. State the values of k and n. Okay, so what are we going to do there? We're just going to use whatever we've been given here. So they're saying if I have 16y to the power 1 over 2, so this will be equals to 16, and then the y is this guy here. So that is 49 over 16, and then x power 4. So that has replaced this y, and then to the power 1 over 2. Okay, so from there, we see that this 16 and this 16 is going to cancel out. So I only remain with 49 x to the power 4, and then to the power half. So now I can distribute this power half, okay, to the 49, and also this 4 multiplied by this power half, I just get 2. So now what is 49 to the power half? 49 to the power half is the same as the square root of 49, which will just be 7. And then I have x to the power 2. So this is the form that they wanted. Okay, they wanted k x to the power n. So now we can get our k and our n. So our n will just be the power there, which is 2. Our k will just be this 7. So k is equals to 7. So you go on the option that will have these correct answers here. So that is option A, right? So we're going to select option A there as the correct answer. Okay, so that was question 1.9. And then let's look at question 1.10. So this is the last question. Okay, this is the last question for section A. So here they're saying what now? Okay, they're saying log P, and then in brackets 4y plus 1 minus log P, in brackets 2y minus 2 is equals to 1, where P is greater than 2 and y is greater than 1. So express y in terms of P. So here they just want to make, they just want us to make y the subject of a formula. Okay, they just want us to make y the subject of a formula. So now remember from the properties of logs. Okay, if I have log of base A and then A minus log of base A again and then B, this here, but the properties of logs, it's the same as log base A and then A over what? B. It's the same as this. Okay, it's the same as this. So that's what we are going to use here. And then from here, also remember the property BAM. Okay, so meaning base to the power answer is equals to what is in the middle. So whenever you write a logarithmic function, okay, you are going to have the answer part, the middle part, and the base. So for example, okay, for example, if I write log base A, okay, of A is equals to x. This here, like a small letter a, is what we are calling the base. The x there is what we're calling as the answer. The a there is what we're calling as the middle. So it makes this BAM. So if you are converting, okay, from the log to the exponential, you follow base to the power answer is equals to what is in the middle. So you move like this, okay, like that. So it means the base will be a to the power answer is equals to what is in the middle. So we're also going to use this property. So let's start. So there we have log of base p 4y plus 1 minus log of base p 2y minus 2 is equals to 1. So since we have a minus here, we can use this property. Okay, so I'll just write it as log of base p and then 4y plus 1 divided by 2y minus 2 is equals to what? 1. And then from here, I'll use my BAM now. Okay, so base is p to the power answer 1 is equals to what is in the middle, so which is 4y plus 1 over 2y minus 1. But p to the power 1 is just p. So this is p over 1. I can cross multiply. So if I cross multiply, I get 2py minus p is equals to 4y plus 1. So I want to make y the subject of a formula. So I'll take all the y's to the left-hand side. So it will be 2py. This one goes to the other side. So it will be minus 4y is equals to, this one goes to the other side. Going to give me what? Oh, no. This one here was the 2. I don't know why I wrote a 1. There's a 2 there. So this is 2. It means there I have 2p like this. Okay, so the 2p goes to the other side. So I have 2p, okay, 2p plus 1 like that. And then I have that. Okay, so now I can factorize the y from this expression. It will just be y. And then I'm left with 2p minus 4 is equals to 2p plus 1. Okay, so from there, what do? We are going to divide by 2p minus 4, even here, 2p minus 4. So we can even see the answer there, right? So y is equals to 2p plus 1 over 2p minus 4. Okay, so that's what we have. So we check on our options. We see that this option is on option what? D. So we are going to select D as our best answer. Okay, so any questions there? Okay, so thank you so much for watching this video. These questions were section A of the mid-semester exams that we did. Okay, but we've also solved section B and section C. Okay, so this is the full exam paper that you can see there. Okay, so that's section A, section B, and section C. So we have videos for all these sections here. We've solved all the questions in this paper. Okay, so if you'd like to actually access the full videos as you prepare for your exam, you're very much welcome, okay, because most of the questions from this mid-semester exam are going to appear in the final exam, okay, or similar questions, okay? So you don't go to the exam without passing through the mid-semester exam, okay? Then you are kidding yourself. So you need to go through this paper, okay? And then you also have to go through your quiz, your 2 tests, and the tutorial sheets. Then you're well good, okay? You're home and dry. So all these questions here, okay, we've solved them, and they're there on our website, okay? So if you'd like to access them, you can just check the link in the description below here. Okay, you're going to find 3 links. 1 is for our website. Okay, 2, it's for it's the link for our mobile app. So on our mobile app, you can actually download the videos. Okay, download the videos and watch them offline, anytime, anywhere, at your own time. Okay, so you don't always have to use bundles when you are using our learning platform. And then the other link is a registration guide. Okay, so it will show you how you can create an account on our website if you do not have. If you have, it will just show you how you can register for this course here with math. Okay, so that you can go through the videos for the mid-semester exam, the tests, and the tutor sheets. Okay, so when you go on our website, you're going to find something like this. Okay, let me erase this part. Okay, so you can register for any course that you want. Okay, the one that you feel is giving you trouble. So these are the courses there for the pre-meds. So if I go in math, okay, I'll go in general mathematics. You can see that I have past quiz, test, and exam papers. So this is where you find your past papers. And in here, that's where you find your tutor sheets and the assignments. Okay, here you find just lessons and topic videos on each topic that you did. So if I go in the tutor sheets and the assignments, okay, you see that there are a lot of universities. So you go in your university. So I'll go in Unilus because that paper was for Unilus. Okay. If it depends if you're in semester 1, semester 2. Okay, for this video, I'll go in semester 1. I'm going to find the video solutions to all the tutorial sheets. Okay, so once it opens, you see there's January intake videos. There's also 2025 July intake. So you go in the July intake order. You're going to find the videos for the assignments and the tutorial sheet, all of them. So from tutorial sheet 1 all the way up to tutorial sheet 7. We solved all the questions here. You can actually learn. Okay, I know it's a few days to the exam, but you can actually learn. Okay, you can actually learn and pass that exam. So these are the tutorial sheets. If you want the past papers, okay, uh, you go to these past quiz and tests exam papers. You open. Again, it's the same formation. You go to your university, Unilus. You're going to find first semester, second semester, it depends where you are. Okay, so you go to the video solutions, you're going to find the videos here. Okay, so there are tests and the mid-semester exam. So you can actually use these things here to learn at your own pace, at your own time. So thank you so much for watching, and I wish you all the best as you write your final mathematics exam. This has been Tutor Poul. I will meet you guys when you cross over to second semester. Bye-bye.